Hello everyone, my name is Anisa and this is my honors project for Physics 151. So the topic of my project is Jupiter's moon Io, which is the most volcanically active body in the solar system. For this project, I have done some research with the help of my mentor, Professor Lisa Havig, and in this presentation, I'll be reporting what I have found. The goal of my research is to find out what is powering the volcanoes on Jupiter's moon Io. I want to figure out how tidal forces are responsible for the generation of heat and how they're arising from the gravitational interaction. And also, I thought it would be interesting to compare it to our Earth moon system. Now, let's talk briefly about Io. So Io is one of the 79 moons of Jupiter discovered till now. When in 1610, Galileo looked from his telescope, he discovered Io along with 3 other moons, which is why Io is sometimes called one of the Galilean moons. And among all of the moons of Jupiter, Io is the closest one to orbit Jupiter. Now, if you look at the picture of Io here, we can see something unusual going on its surface. There's different color formations of yellow, orange, red, blackish brown on its surface. These are caused by the high sulfur and sulfur dioxide content, which explains that Io is bursting with volcanic activities and it is the most volcanically active body in our solar system. Now moving on to the volcanoes on Io, these volcanic eruptions were first observed by the Voyager spacecraft in 1979, and they have been also witnessed by the Galileo spacecraft that recently detected more than 100 erupting volcanoes on Io. And scientists speculate that there may be as many as 300 volcanoes on Io. So this volcanic activities, these on Io, it is so relentless that there are no signs of impact on its surface because they're rapidly filled in with volcanic material soon after they appear. In the picture, we see different regions of Io and they have been named after various mythological associations with fire and volcanoes, which is pretty obvious because of Io's volcanic nature. So the question comes to our mind, what causes Io's volcanoes? The answer would be tidal forces. The tidal forces and the friction between different layers of Io cause the heating of the interior of Io that powers this enormous volcanoes on Io. This picture here shows different volcanoes on Io's surface. So what exactly are the tidal forces? The tidal forces are the gravitational pull exerted by a body that can cause another body to compress and stretch within the gravitational field, as we can see in the picture right here. And the tidal forces are largely dependent on the distance between two bodies. We can find the equation of tidal forces from the equation of gravitational force by differentiating the force of gravity with respect to the distance. Now notice that gravitational force is inversely proportional to the square of the distance, whereas the tidal forces are inversely proportional to the distance cubed, which suggests that tidal forces are largely dependent on the distance between two bodies. So this is the equation that we use to determine the tidal forces of different planets and moons. From this equation, we can see that the tidal force will be greater. The tidal force will be greater if the mass of the planet is large and the distance between the planet and moon is less. Now let's calculate the tidal forces of Jupiter on Io. So plugging in the values of gravitational constant, mass of Jupiter and Io, radius of Io, and distance between Jupiter and Io, we can find out the tidal forces of Jupiter on Io, which is the numerical value is 5.46 times 10 to the 20, and this is a huge force. Now, if we look at the picture of Jupiter and Io side by side, we know that Jupiter is the most massive planet in our solar system, more than 318 times as massive as our Earth. And this tiny moon, Io, orbits very close to Jupiter. And from the tidal force equation, we know that these are the two major causes of greater tidal force. As a result, Io is highly affected by Jupiter's gravitational pull. As we can see in the picture, the neighboring moons of Io are Europa, Ganymede, and Callisto. Now, if Io were Jupiter's only moon, it would not experience such strong internal stresses. But the other moons cause Io's orbit to be elliptical, so it changes its distance to Jupiter as it orbits. The other moons also exert a gravitational pull of their own, which causes additional stresses on Io. As a result, Jupiter's gravity coupled with the gravitational pull of Io's neighboring moons cause Io's surface to deform at a great extent. The tidal heating is the heating of the interior of Io. So imagine you have a spoon and you're bending it back and forth. So it will ultimately break in half, right? And when you touch the crease line, you can feel that it's very hot. Now think what happens when Io is deformed continuously. So if just bending a spoon can create that much heat energy, the flexing of Io can create and can generate enough heat to cause these volcanoes. Also, the heat can be generated from the friction between different layers of Io. In the picture right here, we can see the internal structure of Io. So the core that is gray is believed to be composed of iron and iron sulfide. And the surrounding the core is the yellow orangish is a mantle of partially molten rock. So now, even though the surface of the surface temperature of Io is bitterly cold, since it doesn't have an atmosphere to trap heat, but however, its volcanoes can rise the temperature up to 1600 degrees Celsius. Now let's compare the tidal forces on Io with one of its neighboring moon, Europa. If we take the ratio of tidal forces on Io and Europa, cancel out some terms, and plug in the values, we'll get that tidal forces on Io is 8.7, almost 9 times greater than the tidal forces on Europa. Now, if we compare tidal forces of Jupiter on Io with something that we're more familiar with, that is our Earth-Moon system. So after plugging in the values of Earth and Moon's mass, radius, and distance between them, we'll again find the tidal forces on Io is so much greater, that is about 100 times greater than the tidal forces on Earth. So from all of my research findings, I have come to this conclusion that the volcanoes of Io are caused from the heat that is generated due to the tidal forces of Jupiter and neighboring moons. And these tidal forces, they're the result of the gravitational pull on varying distance. Also, from the previous comparisons, it is proved that Io is experiencing the most tidal forces in our solar system. And these are the 5 sources and references I have used for my research. With that, I would like to conclude my presentation. Thank you everyone for watching my presentation and have a wonderful day.